The areas covered in the Type 1 exam are recovery equipment, recovery requirements, recovery techniques, and safety. Persons handling refrigerant during the maintenance, service, or repair of small appliances must be certified as either a Type 1 technician or as a universal technician. The exception of this rule is motor vehicle air conditioning, which is covered under Section 609 of the Clean Air Act. If a system requires refrigerant line connections or charging in the field, even if it's less than 5 pounds, the technician must be certified as Type 2. Both Type 1 and 2 certifications include appliances that use medium pressure, high pressure, and very high pressure refrigerants. High pressure refrigerants have a pressure between 155 pounds per square inch gauge and 340 pounds per square inch gauge at a liquid phase temperature of 104 degrees. Medium temperature refrigerants have a pressure between 30 pounds per square inch gauge and 155 pounds per square inch gauge at a liquid phase temperature of 104 degrees. This can be found using a pressure temperature chart like the one in the back of the manual. The definition of small appliance includes products manufactured, fully charged, and hermetically sealed in a factory containing 5 pounds or less of refrigerant. Examples of this equipment include such things as water coolers, window units, refrigerators, freezers, dehumidifiers, residential ice machines, and packaged terminal air conditioning systems. Remember, split systems are not in the Type 1 category and may not be serviced by persons unless they are certified in Type 2. The sale of CFCs, HCFCs, HFC, and HFO refrigerants to service or install refrigeration and air conditioning equipment is restricted to technicians who are EPA certified in refrigerant recovery. MVAC-like systems or automotive systems do not meet the criteria for Type 1 appliance certification, no matter the type or quantity of refrigerant. HCFCs such as R404A cannot be used for new Type 1 appliances. New appliances can only be manufactured with refrigerants approved in the EPA's SNAP program, which is the Significant New Alternatives Policy program. When retrofitting or converting a system to use a different refrigerant, only EPA-approved substitutes can be used. Remember, there is no such thing as a drop-in substitute. EPA does not approve any substitute refrigerant as a drop-in replacement to service an R22 system or any other system. A couple of reasons for this is that you cannot mix refrigerants, or when retrofitting to another refrigerant, something will be affected in the system, whether it's the pressure or the system capacity or both. When retrofitting or converting a system to use a different refrigerant, only EPA-approved substitutes can be used. Remember, there is no such thing as a drop-in substitute. EPA does not approve any substitute refrigerant as a drop-in replacement to service an R22 system or any other system. A couple of reasons for this is that you cannot mix refrigerants, or when retrofitting to another refrigerant, something will be affected in the system, whether it's the pressure or the system capacity or both. All recovery equipment used during the maintenance, service, or repair of small appliances that use CFCs, HCFCs, and HFCs refrigerants must be certified by an EPA-approved laboratory. When opening a Type 1 appliance containing a regulated refrigerant to perform maintenance, service, or repair, either passive recovery or a self-contained active recovery system can be used to remove the refrigerant. A domestic refrigerator is an example of an appliance which it would be permissible to use a passive recovery device. System-dependent or passive recovery equipment used for an appliance containing an HCFC or HFC is limited to a maximum charge of 15 pounds, although the maximum charge in a small appliance is 5 pounds. The 15-pound limit is due to being able to use passive recovery for some Type 2 appliances. Maintenance practices for recovery equipment should include checking for refrigerant leaks and the oil level if required on a regular basis. You must make sure the recovery tank is not overfilled. A refrigerant scale or tank internal float device are acceptable for monitoring that the fill level in the recovery tank does not exceed 80% of the total capacity. When recovering a regulated refrigerant from a Type 1 appliance, there are three levels or rates of recovery. If the compressor in the appliance is operational, 90% of the refrigerant must be recovered. If the compressor in the appliance does not operate, then 80% of the refrigerant must be recovered. In either case, with an operational or non-operating compressor, a 4-inch vacuum must be achieved when using a self-contained or active recovery unit. The recovery machine has to be rated under AHRI Standard 740 to be used. All refrigerant recovery devices must have either manually closed or automatically closed valves to prevent loss of refrigerant from hoses when connecting or disconnecting the equipment. When accessing a system or attaching a manifold gauge set to check system pressures, hoses with a manual or self-sealing valve should be used to minimize the release of refrigerant. Although these are rarely used anymore, when filling a charging cylinder with a CFC, HCFC, or HFC refrigerant, the refrigerant vapor that is vented off of the top to allow liquid into the bottom of the charging cylinder must be recovered. A vacuum pump made for system dehydration cannot be used to directly recover refrigerant. However, it may be used to evacuate an empty recovery cylinder to be used as a recovery device on a system with a few ounces of refrigerant. Remember, a positive pressure on either the inlet or the outlet of the vacuum pump may cause damage to the pump. Never apply pressure to a vacuum pump. R600A is a flammable hydrocarbon refrigerant approved for use in newly manufactured household refrigerators, freezers, and combination refrigerator freezers. Hydrocarbon refrigerants are not approved for retrofit in existing household refrigerators that are designed for other refrigerants. R290 is not the only approved hydrocarbon. New SNAP regulations have approved R290, R450A, and R600A refrigerants for newly manufactured household refrigerators. EPA does not require leak repair for small appliances, but leaks should be repaired whenever possible to conserve refrigerant. Make sure the valve cores are tight and the caps are back on the straighter ports to prevent accidental depression and leaking from the valve cores. Before recovering a refrigerant, it is necessary to know the type of refrigerant that is in the system. This is to prevent mixing of different refrigerants in the recovery cylinder. Also, recovery cylinders must be clearly marked as to its contents. When servicing a system with R744, safety precautions must be followed. CO2 carbon dioxide is a very high pressure refrigerant and generally does not need to be recovered. The only valid means to check for contaminated refrigerant in the field is to do a comparison using a pressure temperature chart. When checking for non-condensables inside a recovery cylinder containing a refrigerant, the technician must allow the temperature of the cylinder to stabilize to either the room temperature or ambient temperature before taking a pressure reading for comparison using the pressure temperature chart. Remember, there must be some liquid in the cylinder to do the comparison. If after a pressure measurement is taken and compared to a pressure temperature chart, a technician suspects that the refrigerant in a recovery cylinder is contaminated or the pressure temperature relationship does not match, the refrigerant should be turned into a reclamation facility. Remember, some reclamation facilities may refuse to accept mixed refrigerants or they may charge extra for processing or destroying it. The service aperture or process stub typically used on a small appliance is a straight piece of tubing that can be accessed using a Pearson type access valve to add or remove refrigerant. After installing and opening a Pearson type access valve, the recovery procedure does not need to be performed if the pressure in the appliance is at 0 pounds per square inch gauge. After installing an access fitting on a sealed system, the fitting should be leak tested before proceeding with recovery. Because solderless type Pearson valves tend to leak over time, they should be removed and the process stub resealed to prevent leaking after completion of the repair. When using the passive system-dependent recovery process for small appliances, the refrigerant can be captured in a non-pressurized container, such as the refrigerant bag shown, or an evacuated recovery tank. When using passive recovery devices on small appliances with a non-operating compressor, it is essential to take measures to help release trapped refrigerant from the compressor during the refrigerant recovery process. Heating the compressor with a heat gun and striking it with a rubber mallet will help free refrigerant that may be trapped under the oil in the compressor crankcase. Remember, never use an open flame on a compressor. The oil can burn and the refrigerant can decompose into a poisonous gas. When using passive recovery process on a system with a non-operating compressor, both the low and the high side of the system must be accessed for refrigerant recovery. Accessing both sides will improve the speed of recovery. Also, on a frost-free refrigerator, energizing the defrost heaters to increase the refrigerant's temperature will vaporize any liquid in the evaporator, leading to a higher pressure that will help push refrigerant out of the appliance into the recovery device. An appliance with a completely restricted metering device requires only one access valve on the high side of the system if the compressor operates. The compressor can be operated pumping refrigerant from the low side into the high side, allowing the high pressure refrigerant to flow into the recovery device. When using an active recovery machine, non-condensables in the refrigerant being recovered can cause excessive pressures on the high side of the recovery machine and also the recovery cylinder. As long as there's liquid refrigerant present and no impurities or non-condensables in the refrigerant cylinder, the pressure and temperature should match what is shown on a pressure temperature chart. The approximate pressure of an R134A cylinder stored in a room at 80 degrees temperature will equal a pressure of approximately 87 pounds per square inch gauge. Looking at the pressure temperature chart, the left column is the temperature and the next three columns to the right are the pressures for R134A, R22, and R410A. If we look at 80 degrees indicated by the red arrow and read across to the 134A column, the corresponding pressure is 87 pounds per square inch gauge. During system recovery or repair, a pungent odor detected from the refrigerant normally indicates a compressor burnout. The technician should watch for signs of oil contamination when recovering refrigerant from a system that has experienced a compressor burnout. The system may have to be flushed according to the manufacturer's procedures. When nitrogen is used to pressurize an appliance for leak detection or to blow debris out of the system, the nitrogen may be vented into the ambient air. Also, the nitrogen tank should be equipped with a pressure regulator to reduce the nitrogen to a safe working pressure. Maximum test pressures for the low and high sides are normally indicated on the appliance's data plate. When nitrogen is used to pressurize an appliance for leak detection or to blow debris out of the system, the nitrogen may be vented into the ambient air. Also, the nitrogen tank should be equipped with a pressure regulator to reduce the nitrogen to a safe working pressure. Maximum test pressures for the low and high sides are normally indicated on the appliance's data plate. Household appliances charged with flammable HC refrigerants require permanent safety markings. These markings must be on or near any evaporator, exposed refrigerant tubing, machine compartment, and the exterior of the refrigerator. The location for the surface access must have red markings on the lines extending 1 inch in either direction. When recovering refrigerants or just working on any system, safe working practices should be followed. This includes wearing safety eyewear and butyl-lined gloves when connecting or disconnecting refrigerant hoses. Refrigerants will displace oxygen because most are heavier than air. A very large refrigerant leak in an enclosed area can cause suffocation. If a large leak of refrigerant occurs in an enclosed area and there is no self-contained breathing apparatus available, vacate and naturally ventilate the area. When servicing an appliance, care must be taken to avoid overheating refrigerant. CFCs and HCFCs refrigerants subjected to an open flame or high temperatures can decompose into a phosgene gas or produce hydrochloric or hydrofluoric acids in the system.